All right, we'll look at 3.2, which is perfect squares, perfect cubes, and their roots. This is section 3.2 in your actual textbook. So the main connections, if you want to pause this video and give this a try, I will do it for you after. All right, so a Rubik's Cube is a 3x3 face. So what is the area of one face of the cube? So area is length times width. Now, in this case, we could say it's length squared because the width is equal to the length. So area is 3 units by 3 units, so we get 9 units squared as our answer. So why is this a perfect square? This is a perfect square, the number they're talking about, not the shape. The area is a perfect square because I can square root the area. This is because the area is 9, and I can take the square root of 9. It is a whole number. It works out perfectly, so it is called a perfect square. So what is the volume? The volume would be length times width times height. Now width and height are all the same as well because it's a square, so I can say that this would be length cubed. So this is 27 units cubed. 3 times 3 times 3. So again, try and pause this and decide if these are a perfect square, meaning they could be square rooted, or a perfect cube, meaning they can be cube rooted, or neither. If you're trying to cube root in a TI calculator, what you're going to need to do is press Math, and then you're going to select option number 4. Okay, so you can either scroll down and press enter, or you can actually press number 4 in your calculator, and it'll say this. So, for instance, if you want to cube root 325, it should look something like this. And then you do get the cube root of 125 is 5. Okay, so go ahead and test these. I would test them as a square root first. Anything that's a perfect square will have a good answer. If it's not a perfect square, it could be a perfect cube. So test those ones that are left over. And if those don't work, then it's neither. Going through, 121 is a perfect square. The square root of this is 11. All right, so perfect. Undo. So a perfect square, and the answer is 11. 101 is not a perfect square, so you test the perfect cube and you find that it is neither. 125 is not a perfect square, so you test the perfect cube. We just did it. It is a perfect cube. The answer is 5. 144 is a perfect square. The answer of the square root of that is 12. 130 is not a perfect square, so you test the perfect cube, and that is not going to work either, so it is neither. 169 is a perfect square. The answer is 13 when you square root it. And 196 is a perfect square again. When you square root it, the answer is 14. So make sure you know how to select the cube root. Any number that can be represented as the area of a square with a whole number side length is called a perfect square. The side length of the square is the square root of the area of the square. Now, that's a lot of words. The area of a square with a whole number side length. So let's say we have this square with a side length S. Now, of course, each side is going to be the same. So the area of this squared, we could say, is S squared. What they're saying in the second statement, the side length of the square, is the square root of the area of the square. Okay, so the side length is equal to the square root of the area, which of course works in this case. S squared, the square root of anything squared is itself. These cancel. All right. Square roots can be written as just a regular square root, or you can actually put the number out front. Now, when we have just a square root, we never put the 2. Okay. It's assumed. Any other number we have to write there. Otherwise, we'd assume it's a 2. All right. Determine the square root of 11,664. So, we are going to square root. We don't need to write the 2. 11664. The square root is the answer to this. We should know where the square root is. If you have a TI, you're going to press second, the yellow button, and it's x squared because you're going to access what's above it in yellow, and that should put a square root into your calculator. Now, when you calculate this out, we get 108. So the square root of 11,664 is 108. This means that 108 times 108 will equal 11664. All right. Any whole number that can be represented as the volume of a cube with a whole number edge length is the perfect cube. Now, this is really similar to what we just drew. Okay, we have this perfect cube. So, edge length, I'll just use L in this case, I guess. And I need this one. The volume of the cube is length times length times length, which is length cubed. So, again, the side length of the cube is the cubic root of the volume. So, the side length L is equal to the cubic root. Okay, instead of a square root, we have a cube, so a 3 up there, of the volume of the cube, which is the cube root of L cubed. And again, those cancel and we're just left with L. So the cube root can be written as the index, the radical, and the radicand. Okay, so the index is this little small number in the corner, and it tells us what root we are doing, whether it's a square or a cube or a fourth or a fifth or a sixth, whatever it is. Okay. The radicand is the number underneath. I'm probably never going to use that word. The radical is just the square root sign. Okay, the root sign. Okay, determine the cube root of 9,261. So we will just write a cubic root of 9261. Again, if you have a TI calculator, you're going to hit math. And then you're going to select number 4, which is the cube root, and it'll do of something. Now, if we had more than a cube root, that's the only one that's listed there. We can also type 3 into our calculator, select math, and then we're going to hit option number 5, which is the xth root of some number. Okay, so if x was 4, I would want to put a 4 in first. What happens is we're going to get 3 root x of something. Whatever this number is actually what x is. All right. Calculating this out in our calculator, it's 21. This means the cubic root of 9,261 is 21. This means that 21 times 21 times 21, so itself 3 times, is 9,261. Determine the side length of a square whose area is 225x squared, y to the 12, m to the 4. Okay, so again, area is equal to a side length times the same side length. Okay, which we could say is the side length squared. So therefore, what we need to do is we need to square root this area to find the side length, okay? Again, because area is equal to the side length squared. I have the area, I'm looking for just the side. To get side by itself, I need to square root. Okay, so the side length will equal the square root of the area. Okay, so the side length is equal to the square root of 225 x squared y to the 12 m to the 4. So, square rooting the number, the square root of 225 is 15. Now we have a bunch of variables we need to work with, okay? So, x times x is x squared. Therefore, the square root of x squared is just x, okay? Again, because x times x equals x squared, the square root of x squared is x. We need to do that for all of our variables here. Now we need two that actually equal y to the 12th. So what we get is y to the 6 times y to the 6 is equal to the y to the 12. Okay, again, this is because we add our two exponents here. 6 plus 6 is 12. Therefore, the square root of y to the 12 is y to the 6. Okay, last one here, m to the 4. Two that are identical that add their exponents. So m squared times m squared is m to the 4. Therefore, the square root of m to the 4 is equal to m squared. All right. So we just square rooted each little piece individually and multiplied them together at the end. All right, the surface area of a die is 600 millimeters squared. What is the volume of the die? So if I have the area, I can find the side length of our dice. With our side length, we should be able to find the volume of the whole thing. So the side length is equal to the square root of the area from our previous page. So the side length is equal to the square root of 600. The square root of 600 is 24.5 millimeters. Therefore, the volume will equal length times width times height. And the length, the width, and the height are s, so it's s cubed. So 24.5 millimeters cubed is 14,706 millimeters cubed. Okay, if you used your exact answer in your calculator, you're going to get a little bit of a different answer here. It becomes 14,697 millimeters cubed if you used the exact. Either would be acceptable in this case. So go ahead and take a look at your demand line homework here and get some practice in on looking at perfect squares, perfect cubes, and their roots.